Welcome to this DairyNZ Technical Series podcast, channeling the right tools for flood management and runoff from the December 2018 issue. Technical Series is about moving science from theory into action, giving farmers real tools to improve their businesses. Listen to this podcast to understand what a two-stage channel is and how two-stage channels can be used to manage farm waterways, increase flood capacity, and absorb and transform nutrients. This article is by Catherine Febria and John Harding, CAREX Freshwater Ecology Research Group, School of Biological Sciences, University of Canterbury. Te whare wānanga o Waitahi. Before you hear the article, let's chat with DairyNZ's Aslan Wright-Stow about two-stage channels. Aslan, tell us about your role at DairyNZ.
So I'm a water quality specialist by training. My role at DairyNZ currently is Environment and Catchment Manager. So I lead a team that has a role of identifying environmental issues and finding solutions for those.
What exactly are two-stage channels?
The two-stage channel is essentially an artificially created floodplain and these are established on existing drains. So it's an engineered solution. It's basically taking a modified landscape, a landscape with lots of drains in them, and it's excavating out, and what we're essentially doing is creating a broader floodplain channel. So the majority of water remains in the channel, but when flood flows come up, when it rains, when the water level comes up, then there's an artificial floodplain, and that extends the surface area and the processes that happen within that location, enabling the likes of nutrients to be reduced and contaminants to be filtered.
So by increasing the floodplain, what do we achieve?
So there's a whole range of benefits, but essentially what we see is an increased residence time. It has the ability to slow the speed at which water is moving. Residence time is in the amount of time that water takes to move through a system, through a catchment. So if we can increase that residence time, we can slow the speed at which water is moving through the system, then there's far greater opportunity for natural processes to do their bit. And that has the ability to reduce contaminants. It can reduce nitrogen, it can reduce phosphorus, it can reduce suspended sediments, and therefore has the ability to improve turbidity or water clarity.
Why is this research important to farmers?
Farmers are working really, really hard to improve water quality, and water quality is a key environmental issue, as we all know. So there's limits coming. There's limits for every catchment throughout the country, and so farmers are working hard to meet these limits. And there's a range of opportunities and options that they have. We're looking at a whole series of potential mitigations for improving water quality and mitigating the impacts of land use on water quality. Two-stage channels are a key tool that potentially will help farmers meet those limits in the future.
How does this work fit into the bigger picture for farmers?
It fits into a broader piece of work that we're doing in and around environmental mitigations. So we're looking at riparian buffers, we're looking at constructed wetlands, we're looking at seepage wetlands, all of those sorts of things. This is another tool, if you like, for that suite of mitigations that farmers can potentially use to reduce their land use impacts.
Can you tell us more about the kinds of landscapes or locations in which two-stage channels best work?
There's a real potential for these things in dairy landscapes. Dairy landscapes often have a disproportionately high number of drains and a larger drainage network in the lower catchment areas, the flatter catchment areas. These are where artificial drains have typically been put to enable farming to take place.
Farmers are concerned about nitrogen and phosphorus. How do two-stage channels help reduce the impacts of these and other contaminants?
For particular contaminants, there's a real opportunity to reduce. So, for example, to reduce phosphorus and nitrogen, and turbidity. So the amount of suspended sediment or the amount of sediment in the water. In terms of reducing sediment and in terms of reducing phosphorus, and often phosphorus is bound to sediment, so the ability for these things to reduce that comes by slowing flows, as we've already discussed, and letting that drop out on those extended flood plains or those extended channels. In terms of nitrogen reduction, the way these things work is that we increase the area in which denitrification can happen. Denitrification basically is taking nitrogen, and it's through natural processes converts that into nitrogen gas. We need certain environmental conditions for that to happen. We need the right bacterial community. We need the right conditions with a lack of oxygen. These two-stage ditches have the ability to increase that and therefore increase the amount or the process of denitrification in these areas.
What different processes or activities take place in the stages of a two-stage channel?
Yes, so what happens there is at low flows, typically you've got a lot less contaminant or a lot less water quality issue. A lot of the water quality issues happen at higher flow when you've got increased sediment runoff, and often that overland flow has increased nutrient loading as well. So if we create an environment where we can increase those processes that reduce or get rid of those other contaminants which disproportionately arrive at high flows, then we're off to a win-win scenario.
How well do two-stage channels work?
Most of the work for these has been done over in the States, in North America in particular, and the studies over there have found that we can get some pretty good return on investment essentially for these things. So for reducing turbidity and increasing water clarity, studies over in the States have found between 15 and 82% reduction during high flow or flood events for sediment and turbidity. So that's a high return. That's a great outcome. In terms of removing nitrogen and the process of denitrification, which I've talked about, studies again over in the States have found that denitrification rates can be between 35 and 49, or so almost 50% higher in two-stage channels compared to channels that don't have those, so up to half again. And in terms of the amount of nitrate or nitrogen removed, those same studies have found that up to 70% more nitrogen is removed via denitrification within two-stage ditches.
Are we seeing these results in New Zealand?
At the moment, they haven't really gained all that much traction in New Zealand. North America is where most of the research on these things has happened. There's a few examples across New Zealand, but not a huge amount. And that leads us to the work that we're doing now, and the work that we're doing with the University of Canterbury and the CAREX group down there. And the aim there is to identify how well they work and look at the current literature and what we already know, which we've done. And the next stage from here is to go about implementing a bunch of these across New Zealand and testing how well they work in the New Zealand landscape and the New Zealand context. But indications are, based on the North American work, that we should see similar, if not better, productivity out of these things.
That was Aslan Wright-Stow, DairyNZ's Environment and Catchment Manager. Now here is Kay Whittle, Technical Series Contributing Editor, to present the article. For photos and diagrams of two-stage channel designs, check this article out as a hard copy and online at dairynz.co.nz/technical series.
Channeling the right tools for flood management and runoff. DairyNZ has been working with the Canterbury Waterway Rehabilitation Experiment Group, otherwise known as CAREX, to investigate the two-stage channel, a promising tool to reduce landscape flooding and nutrients coming off the farm. Nearly 2 decades ago, farmers and natural resource managers in the Midwestern region of the United States of America were looking for solutions to address flooding and riverbank erosion issues on farm. Over the previous 200 years, European settlers had dramatically altered the landscapes to move water off land through extensive drainage networks and into the Mississippi River and the Gulf of Mexico. In recent times, the scale of flooding problems on farms had become so severe that solutions needed to be developed. One of these solutions was the two-stage channel, which reduced flooding on paddocks and improved water quality. In 2014, Professor John Harding of the University of Canterbury visited some of the two-stage channel pioneers, Professor Andy Ward and Dr. Jessica D'Ambrosio from Ohio State University, and Professor Jennifer Tank from Notre Dame University. Together, they viewed two-stage channels of varying ages and designs and reflected on their usefulness in addressing similar issues on New Zealand farms. The University of Canterbury and DairyNZ are now carrying out a scoping study to trial the two-stage channel as a viable farm management tool for New Zealand. The findings of this study are outlined in this article. So what are two-stage channels? Two-stage channels are artificially created floodplains established on existing farm drains. We examined the traditional two-stage channel as designed and trialled in the Midwest USA and found their issues are similar to those experienced in New Zealand. For example, agricultural drainage channels have commonly become over-engineered, straightened, narrowed and deepened, with frequent dredging and mechanical clearance to preserve and maintain drainage function. However, drain maintenance can be costly for a farmer or regulatory agency, while also contributing to negative environmental impacts such as poor water quality. They can also have potentially counterproductive outcomes for farm management, for example, nuisance weeds that require ongoing management. While there's been more emphasis on altering farm practices to help manage environmental impacts, there's a growing realisation that multiple actions and tools can be employed on farm and within waterway networks to improve water quality. Two-stage channels are one such innovative tool. They can offer benefits for agriculture in terms of flood mitigation and water quality and ecosystem outcomes. So what do two-stage channels look like? Agricultural drains are often highly modified straightened waterways. They're generally trapezoidal or U-shaped. In New Zealand and many parts of New Zealand, drains are also connected to subsurface tile drains. The two-stage channel design alters the shape of the channel to accommodate floodplains created on either side of the central channel. Figure 1b and photos 1 and 2 in this article illustrate these aspects clearly. In a two-stage channel design, essentially a drain within a drain, the floodplain widths are about the same width as the drain on either side. Banks are excavated slightly to reduce slope and bank collapse, and the exposed banks are simply grassed over. Hydrological data is used to inform the height of the bench and ensure floodwaters are effectively accommodated. As a result, the channel capacity is increased substantially. Two-stage ditches can be created through self-forming channels. Despite the name, this is still an engineering option that involves excavating out a drain wide enough to establish initial conditions for floodplains and then allowing other features to self-establish over subsequent flooding areas. And that's those meandering extra channels that you'll see in photo 2 in the article itself. Now these offer similar benefits. They require less excavation and they're designed to allow the natural creation of sediment bars and other physical features to form over time. With either of these options, subsurface tile drains can also be accommodated in the design, with flow from tile outlets being deposited on the floodplain benches. You'll need to be aware though that excavating out a drain may require resource consent, of course. So how well do two-stage channels work? The two-stage channel design increases channel cross-section, therefore holding more floodwaters, lowers the power of water to damage banks, and dissipates energy across a larger cross-sectional area. This reduces the flood's power and erosion potential. Variable water velocities are also promoted in the channels, with self-forming channels facilitating the creation of natural meanders and other structural features. These help reduce bank erosion and create more habitat for fish and invertebrates. Over the longer term, two-stage channels have been demonstrated to withstand high flows for more than 10 years after construction. So what are the water quality benefits? Studies in the USA have shown a range of environmental benefits associated with two-stage channels. They can occur either in the main channel or upon the floodplain benches. The key mechanism behind this is ensuring floodwater overtops the benches during flood events or high flows. When that occurs, the speed of the water is reduced and sediment is deposited on the benches, whereas velocities in the main channel should be higher. As water levels drop, pools of standing water carrying sediments and other contaminants are trapped on the floodplains, and nutrient removal can occur in the soils via denitrification. Published studies have shown a number of water quality improvements in two-stage channels, including for turbidity, otherwise known as sediment, phosphorus or P, and nitrogen or N. Turbidity is a key measurement of fine sediments and particulates in the water column, and it's an indicator of sediment loads. Studies have shown significant reductions in turbidity, a decrease of 15 to 82% during flood events. Sites with the widest floodplains had the greatest turbidity reductions, with some suggestion that sediment retention may improve over time, and with further establishment of vegetation, for example plantings, on the floodplains. There's growing evidence too that two-stage channels are effective at reducing P export. Again, this is driven by floodwaters overtopping the benches and trapping P bound to fine sediment particles. Like turbidity, reductions in sediment and P can be encouraged with vegetated benches, but further long-term study is still needed. An additional benefit of the two-stage channel is its capacity for N removal. The primary mechanism for N removal is denitrification. Published studies indicate that there is significant potential for this tool to increase N removal or uptake. Simply, denitrification occurs when floodwaters are trapped on the floodplain and low oxygen conditions are created in the floodplain soils, thus supporting microbes to convert nitrate to N gas. It follows then that an increased floodplain area creates longer water residence time and enhanced denitrification. Denitrification rates can be 35 to 49% higher in two-stage floodplains compared to those without two-stage channels. Another study demonstrated that most denitrification occurs when the floodplains are inundated during a storm event. It found 70% more N was removed via denitrification compared to normal conditions. A source of carbon is also needed to support and enhance denitrification, so vegetation and organic matter, grass, riparian plants, should be encouraged. So what about other contaminants? Other potential benefits beyond flood mitigation and nutrient and sediment reduction have been hypothesised overseas. These include reductions in fecal microbes, heavy metals, herbicides and pesticides. We're not aware of any published data on the ability of two-stage channels to reduce these contaminants, but we agree reductions are also likely for New Zealand waterways. Let's look at cost effectiveness now. An important factor to consider in constructing two-stage channels is their implementation cost and cost effectiveness relative to other mitigation tools like planted riparian buffers or constructed wetlands, which are used for improving water quality outcomes. While few cost-benefit analyses have been conducted, field trials have shown that once installed, several examples of two-stage channels in the Midwestern USA have not required further maintenance, even 12 years after construction. That's according to Dr. Andy Ward. A recent analysis compared two-stage channels' cost-effectiveness to other remedial actions on farm, for example cover crop or wetlands, over a 10 and 50-year timeframe each. It found the initial cost of building the two-stage channel was higher than protecting on-farm wetlands or using cover crops. However, in the long term, the costs evened out due to minimal maintenance. This is supported by evidence from the Nature Conservancy, which suggests the payback period for excavation costs in the USA is about 14 years. You can see this in the Nature Conservancy's graph in Figure 2 in the article, which compares this aspect for the two types of channels, demonstrating estimated cumulative savings over a 100-year period. As mentioned, the payback period of 14 years shows similar savings for both kinds of channels, but after that, the savings for the two-stage channel rise swiftly and significantly over the next few decades in comparison to the single-channel design. Some farmers may initially assume the two-stage implementation requires surrendering productive land to provide space to create the floodplain benches. Well, that's not necessarily the case. In the Midwestern USA, on farms where vegetated buffers were already present along drains, little to no additional land has been required or given up. Due to the excavation required, the upfront costs may be high, but overwhelmingly the data suggests two-stage channels offer an affordable, low to no maintenance, long-term solution in the USA. Tests are still to be carried out in New Zealand. However, we anticipate similar findings, particularly when existing in-stream work costs, such as erosion protection work and drain cleaning, are factored in. Let's talk about the criteria for two-stage channels. Two-stage channels are seen as an exciting new opportunity in New Zealand with potential to help mitigate multiple water quality impacts faced by our farmers and communities. Internationally, two-stage channels have been shown to be highly successful. Indications are that many New Zealand farming landscapes would likely gain similar benefits. Working with DairyNZ water quality staff, our research team will install and monitor a range of two-stage channels, test their performance, identify locations that are appropriate for their installation, and determine regional consenting requirements for implementation. To provide measurable water quality outcomes, waterway reaches should generally be at least 1 kilometre in length. However, some studies suggest 500 metres is the minimum distance for a two-stage channel to measure a difference. That's according to Dr. Andy Ward, one of the authors of this article. Ward has indicated that only about 10% of the roughly 500 two-stage channels constructed to date have failed. However, almost all of these failed channels have occurred due to poor design and construction and installing the channels in the wrong locations. Appropriate location depends on a combination of factors, including sound understanding of the hydrological regime, for example frequency of flood and flood magnitude, soil type and land availability, space on either side of the channel to create floodplain benches. Other considerations for New Zealand catchments include accommodating pivot irrigation, potentially requiring bridges and other infrastructure to be modified, and that spring-fed waterways with stable flows, those less prone to flooding events, may not gain the same benefits when flood events fail to overtop the floodplains. Opportunities that require further testing include integrating the two-stage channel with other tools such as wetlands, riparian planting and sediment traps. You can view this article, its images and its full references in the print version, which is available online free from DairyNZ.
That was Kay Whittle, Technical Series Contributing Editor. Thank you for enjoying this DairyNZ Technical Series podcast. The latest Technical Series is available at dairynz.co.nz/technical series. Like what you heard? Let us know. Email info@dairynz.co.nz.